when it comes to balancing, there are several skills and tricks I'm going to show you that's going to make your life a lot easier. Listen to them, don't listen to them, it's up to you. First off, this maintains the law of conservation. This is kind of like the theme of this whole chapter, is we are making sure the law of conservation, which says we cannot get something from nothing and it has to go somewhere, is followed. Because quite frankly, the universe is going to do this, so we, if we want to know what is going on, have to do it as well. To make sure something is balanced, it needs the same number and type of atoms on both sides of the equation, the reactants at the beginning and the products at the end. We uphold the law, and we can predict what is happening, and we can increase the efficiency of reactions and minimize our waste, which is very important. So basically, you want to pick an element, and I recommend the first one. There's a couple times you're not going to do the first one, but most of the time you'll do the first one. Check that both sides of the arrow to see that that element is equal. If not, change coefficients, the big numbers at the beginning, until they are equal. Do not change subscripts. I repeat, do not change subscripts. Do not change subscripts. And do this until all elements are balanced. Then make sure your coefficients are in the lowest terms. Now you may notice that I don't have a note sheet for this because, like I said, this has got to become second nature to you. You need to be able to do this at the drop of a hat. So that is what you're going to be working on today, is doing this over and over and over again until this becomes so easy you can do it without thinking. Now, I want you to think of balancing like playing volleyball. You're going to hop back and forth with the arrow as your goal line, as the net, until each element is equal. So starting with the first thing, I volley it over. I notice that the magnesiums are already the same, 1 and 1. So that's first one's good. So I'm now going to check the second one. And if I take a look, it's also already balanced. So cool, 1 sodium to 1 sodium. Then I check the third one. And when I look at this, it's not the same. There is an issue because I have 1 at the beginning and 2 at the end. So 1 in the reactants, 2 in the products. So if it's not the same, what I'm going to do is I'm going to throw coefficients to balance the chlorines. The big numbers go at the beginning. Now this does affect our sodiums, but we are just concerned about the chlorines right now. This balances out the chlorines, but it unbalances the sodium. But that's okay, because you can solve that by adding another coefficient to rebalance the sodiums. And now everything is balanced. There's the same amount of magnesiums, sodiums, and chlorines on both sides. So this is the final answer, once it is all balanced. Many videos you will find online with balancing have you do an atom inventory. You know that thing where you write the elements on both sides? Don't do that. It's a waste of your time. It's not very efficient and quite causes there to be more problems than not. And look, feel free to ignore me, but I have seen this over the course of my 16 years. If you do inventories for everything you balance, number 1, you're going to take too long. Number 2, you're likely to make a mistake while you do the inventory, which will screw up your answer. And number 3, you will get frustrated, which will make you not want to do any more work. Do not do an inventory. It is not worth it. Literally just volleyball. 1, 2, 1, 2, 1, 2. Balancing animation you can play with. It's pretty fun. I play the game like normal. It's worth doing. Now, I'm going to go over some balancing because, that's what I do. So, first off, let's get this pointer going. So, this is going to be the example that I'm going to do now. Now, it does automatically play because all of this is designed to have me not here, but it's also supposed to be designed so that if I am here, I can play with it. So, in this situation here, I have got lots of elements. I want to start the first one, which is chlorine. Actually, can I make it, or is that only when I'm recording? Can I make it that it focuses on my, nah, I only have a pointer. Okay, that's fine. So I've got a carbon at the beginning, 3 carbons at the end. I fix it by putting a big 3 right there in the coefficients in the beginning. When I say do not change subscripts, what I mean is don't put the little 3 here. Putting the little 3 there makes this garbage. That now doesn't exist. C3Cl4, nah, that's not work. That's not a thing. So do not change subscripts, only coefficients. You're changing how many we have, not what it is. So I put a big 3 at the beginning. My carbons are now balanced, so I move on to the next one. So check, next. 3 times 4 is 12. Volley to the other side, I've only got a 2. A 6 makes that 12. Volley back, 3 zincs. Volley over, 6 zincs. Volley back, 2 makes that fine. 4 phosphoruses, 4 phosphorus, 4 phosphorus. Done. Now, you may be like, Mr. D, what about this one? This one's got nothing there. That's actually good, okay? Chemists like not writing the number 1. But since you are a high school student, if you want to write the number 1, go right ahead and do so. It's not like something you need. If you were to write this down as an answer, you could just do 3, 2, 1, 6, showing your coefficients, or 3, 2, blank, 6. Either of these work, and they're very useful just to be able to show coefficients. All right, so that is balancing. Now, some videos will tell you instead of starting at the first one, start at the biggest one, and that does work, but I don't know that you guys are up to that yet. So I just start with the first one until you get to a tricky thing, which I will show you. Anybody have any questions now that I have gone over basic balancing, like the simplest balancing that I can do? Questions? Okay. So, and again, you can watch the animation where it goes over piece by piece and explains everything I just did. Now, sometimes you have to go back and fix something that you already had thought was fine. So if I've got this here, nice and simple, 3-parter, should be pretty easy, but there is a problem. See, if I start this at the beginning, I've got 1K, volley over, 3Ks, volley back, fix. 2 ends, volley over, 1 end, fix, volley back. Okay, but wait, I've now screwed up my potassiums. Okay, so what you do is you just erase what you wrote before and you fix it. And that's all you do. Some people think that just because you wrote a number there, you can never fix it. That's garbage. There's erasers for a reason. You erase it, do it again. So there you go. This is the correct answer to that. And again, some of you might be like, well, Mr. D, if we started with this one, then we wouldn't have had to do that. Yeah, but again, if you don't start with the one, you may screw up. You may miss something. So I would just start with the first one until you get good enough to find your own way of doing it slightly better. But that's based on you. I mean, I always start with the first one, even when I've been doing this for years. Now, what you want to do is, again, volley, back and forth, back and forth, back and forth, until everything is fixed. Notice I'm not drawing any inventories at all for this. Now, the other type of problem we have is a proof. When we have to prove something, especially proving the law of conservation, you will notice that it'll say, it'll actually say prove the law of conservation. There are 3 steps to that. Step number 1 is you have to supply the proof itself. To do that, you just do an inventory. So I've got my calciums, got my oxygens. I write this out. I've got 2 calciums, 2 oxygens, and on the other side I got 2 calciums, 2 oxygens. Okay, so there's the proof. Then you need to explain what you just did. You need to explain that. You say, oh, all atoms are equal before and after the arrow. And last but not least, you need to relate it back to the law of conservations. This proves nothing was created nor destroyed. So a proof tends to be pretty wordy, but the nice thing about it is since you are academic chemistry, these will all work. Okay, I save the ones that don't work for honors. Also, the red and the orange will always be the same. Since they work, those two will be the same. So all you have to basically do is do an inventory for each of them and then include the red and the orange. If you understand what I'm talking about, please raise your hand now. Like Mr. D, I get what a proof is. This is going to be easy for me because it should be. These questions should be easy for you. And yet, every year, a good quarter of my students screw up on one of these. I don't know, maybe you're just not used to it. All right, cool. Lower your hands. Thank you very much. So that is a proof. The third and most tricky type of balancing, and it all shows up, is to translate. When you are doing a word problem, it is very tempting to skip these. Do not skip these. I literally could give you hundreds of them. Instead, I picked a selection of the most important. Do each of them. When you are translating, you want to skim for direction, translate each word and phrase, check for problems, and then balance. So I've got this. This is my example 3. Aqueous, magnesium chloride, and solid iron are produced from magnesium metal and iron 3 chloride dissolved in water. Several things pop out at me because I'm used to this. First, it says are produced. You see that? That means that this thing is backwards. So that's my number 1 skimming for direction. This has this and that are made from the other stuff. Well, crap. So there's several ways I can fix this. I could decide to do a backwards arrow instead of a forwards arrow. That would work. But even better than that is to realize, hey, you know something? This is already written in the other order. So what I should do is I should write my arrow first, do the beginning stuff after the arrow, the ending stuff before the arrow. That's the better way to do it. So that's what I'm going to show you. We translate each word and phrase. Aqueous magnesium chloride. Okay, well, first off, when we've got this, we want to draw a dash so that I can balance it. So you start by drawing like an underline space. Then you've got magnesium, which is 2+, chlor and a metal, chlorine, which is 1-, which means I need 2 of those. So this is going to be MgCl2. And it says that it is aqueous. So I'm going to put that there because it's translating. I should put my phases. So again, when you translate, you're going to need phase symbols. I didn't want that. I wanted this. It then says and. And is just a plus sign. Solid iron. Okay. Iron. Solid. Cool. Are produced from magnesium metal. K. Magnesium, which is a solid because it said, it's just a metal. And iron 3 chloride. Okay, so when I'm looking at this one, I have got iron 3, so that's a 3+, chlorine's a 1-, which means I'm going to need 3 chlorines. FeCl3. Now it says dissolved in water, but that just means aqueous. That's all it means. So it's AQ, and there we go. I just did the skim for direction and translate each word and phrase. Now I check for problems. I check, are my things that are alone social? Magnesium and iron are alone. That's okay. Neither of them are social, which means they can stay alone. No big deal. Then I check my compounds. Did I do these correctly? Yep. Fe 3 plus 1 minus, 2 plus 1 minus. Yeah, okay, I did both my compounds correct. Then I check phases. Yep, everything's got a phase. That's from the question. Then I check pluses and arrows separate everything. Cool. After you do all of that, and that's the check for problems, then you may balance. Now, when we balance, we're just going to, again, start at the beginning. We've got 1 mg, good, 1 Fe, good, 3 Cls, 2 Cls, not good. If I've got a 3 and a 2, I'm going to make them both equal to 6 by putting a 2 with the 3 and a 3 with the 2. This also means I've got to go back and put a 3 with this magnesium and a 2 with this iron because of the coefficients I just put. But then everything's golden. And so there you go. That is translating a word problem and balancing said word problem.